Hey up everybody, Yorkshire Fab Shop here again. Now, as you've probably guessed by the title of this video, today we're diving headfirst into the world of bolts and fasteners. Call it a cap head, set screw, nut, bolt, whatever you want to call them. We're going to be discussing threads today. Now, in my opinion, if you ask me what I think about a bolt, or a screw for that matter, now I'd probably go as far as to say it's one of the most important things in our modern world. More important even so than sliced bread. Yes, I really did go there. Now, I think they're so important because if you pick anything up, any device, your mobile phone, your watch, TV, I don't know, your sofa, there is almost certainly a bolt or a screw of some description holding that item together. Now, what we're going to be discussing today is sort of a bit more in depth into the world of threads, how they work, what they're for, what sizes they are, etc, etc. Because that's a little bit of a complex science in itself, and we want to try and simplify it today. So if we take this humble fastener, now there's a couple of names for it. I'd call it a cap head. Others might call it an Allen headed screw, bolt, I don't know, whatever you want to call it. What is it? I know that this is a metric fastener. Metric thread form, metric course to be precise, M16, and what more do you want to know? Material? Yeah, obviously. But what makes that metric thread? What defines that as a metric fastener? Well, for starters, we've got the outside diameter and the pitch in metric terms, because there's certain ways of measuring that, whether you're talking about imperial or metric. So back in the day, back in 1841, sometime around there, a smart gentleman called Joseph Whitworth decided he was going to standardise these things. Although the metric system wasn't invented back then, we're talking about British standard. So British standard Whitworth, British standard fine. And on those particular fasteners, there were two determining sizes that you needed to be aware of. That is the outside diameter and the pitch. So the pitch was measured in threads per inch, TPI. The diameter was measured in an imperial measurement, so inches, quarter inch, half inch, eighth, whatever you want. Later on, in the 1940s, metric system sort of took hold. The metric system was standardised, and then shortly after, we had an American system as well, obviously because they wanted their own standard. So we had metric and then unified. So the difference there is the metric system decided to go slightly different in that the pitch form wasn't going to be measured relative to an inch, it was going to be measured relative to itself. So in a metric form, the distance between the two peaks or the two troughs of a thread would be measured in a metric measurement. So M16, I think it's 2mm pitch. So the distance between each of the peaks of the thread will be exactly 2mm, give or take. American unified thread works on a similar scenario to the old Whitworth stuff, in that you've got threads per inch and an imperial diameter. So with a bit of history about them, what we really want to get into the nitty gritty is what is the difference between this, for example, and something like this, which I know is an imperial fastener. Well, for starters, make it a bit fairer, we'll compare like to like. So we've got an M10 fastener, and I think this is a 5/16 to the top of my head. I haven't measured it in a while, but I think it's 5/16, or 3/8, and then we've got M10, so somewhere near to one another. But just quick observations, we can quite clearly see that the threads are much closer together on this than they are this. We've got metric course, M10, 1.5mm pitch, and we've got 5/16, I think, or 3/8. Yep, 3/8, so 9.6mm, something like that. So we can see, yep, the thread's totally different. Now, what else is different? Apart from the pitch, obviously the outside diameter is different. Metric and imperial do differ slightly in thread shape as well. The old Whitworth threads tended to be more rounder on the peaks and in the troughs. Metric threads tend to be more peaky, more pointy. But aside from that, if we cut the cross section of these threads and we're looking at the triangle side on, the angle of the thread, so the inclusive angle between the peak of the thread in the old Whitworth and fine British Standard threads of 55 degrees. Metric and unified was 60. Whether it makes much of a difference or not, I'm not to say. I suppose if you calculated it, did a bit of science, you could say that, well, one's slightly stronger than the other, but you get the idea. But 5 degrees difference. Something to be aware of, because you were trying to measure and they were two very close. You could determine which one's which simply because the thread angles are different. Now, I would imagine a lot of people have seen these before. Those that haven't, these are the tools that are required for creating threads on a plain shank, plain round bar, round stock, provided that you've got the correct diameter to start with. So if you wanted to externally thread an item, then you would need to ensure that the diameter was, say you wanted to cut an M12 thread, you would want an outside diameter at least slightly smaller than 12mm, because if you get exactly 12mm, you can have difficulties. If you're aiming for just under 12mm, so 11.95, 11.9 push, it's tolerance bands, of course. Aim close to 12mm, and then you'll be able to run that down no problem. These, same principle, drill an hole somewhere around the region of the root diameter, so the smallest diameter of the thread. Plenty of charts about that tells you what that is. Wind that in, cuts the thread, happy days. What if you've got a fastener or an item that you need to thread, but you either don't have a die nut or you don't have the correct tool to cut it on the lathe, for example? What do you do then? You haven't got a lot of options, unfortunately. You have either got to manually cut it or screw cut. Now, if you're in my situation, lots of things are metric these days. I've got an Imperial lathe. Can I cut metric threads on an Imperial lathe? And that's what we want to discuss today. So what I've done is brought you over to my rather humble little lathe. Old British machine. Data plate that gives us everything we need to know. Now, this machine does actually specify metric cutting. If I open the the change wheel cover, which is just here, in there, well, you can't really see it, that chart does give you information on how to cut metric threads with a 127 tooth wheel, which is quite commonplace, obviously. So 127, half of 25.4. It does work somehow. Some magic, it works anyway. So on this rather comprehensive, like I said, Norton style gearbox, we've got 2, 4, 6, 8, 32. Wow, I didn't realise there were that many. 32 individual threads per inch. So starting with the smallest, we've got 56 right up to 4 threads per inch. A really good selection if you're doing Imperial work. Obviously, we want to do some metric threading. So we want to know, is there any of these that are anywhere near a metric pitch? So let's take this as an example. M12 cap head, Allen headed screw. Now my goal today, this thread's not long enough. I need this threaded section to be at least 50% longer than it is now, for argument's sake. Got a couple of options. Could run a die nut down it, which, yeah, would work. Now just bear in mind that this is a 12.9 fastener, so it's quite tough. Some die nuts, if they're a bit past it, might struggle to thread that. Or maybe I haven't got an M12 die nut, which I actually don't have, unfortunately. So what are my other options? Well, I've got a lathe and it screw cuts. But as discussed, it's an Imperial lathe. So can I thread that on an Imperial lathe without a 127 gear change wheel, because as many of you all know, that's the option for metric threads if you've got an Imperial lathe. Stick a 127 tooth gear on it, and the charts usually included with the lathe will tell you that a certain combination of change wheels will result in a metric thread of some description. What if you haven't got them as well? So I haven't got 127 tooth gear. Can I thread M12 onto this fastener with an Imperial lathe? Well, the answer's sort of yes, but also sort of no. So it's sort of yes because, as we'll demonstrate later, there are actually some very close combinations of gears and feeds on a relatively standard lathe that will almost cut an M12 pitch. And in the same sense it won't. Let me explain. So what I've put together is a little bit of a chart, visual aid for me, with a bit of calculating to tell me whether or not I can, in theory, thread a metric thread onto an Imperial, using an Imperial machine. So what I've done is, because I've got a Norton gearbox on my lathe, so it's quite a comprehensive gear set. Ranges from something like 56 threads per inch to 4.5 or 4, somewhere in that region. So it's a really vast range of threads there. But the question is, do any of them tie up with a metric thread? Well, as it turns out, provided your tolerances aren't that close, they kind of do. We're starting at the top, small stuff. Probably not going to be a threading M3, M4, M5 on a lathe. But you can, and we're very close. So to give a bit of background, what I've done is I've sort of decided that anything less than 2.5% total error is probably going to be all right. So the 2.5% is basically the gain or loss of threads per inch or metric equivalent. So if we've got a 52 TPI thread, the pitch in metric would be 0.488 millimeters. So what that means is that after a length of 10 threads, obviously we'll times that by 10, so it'll be 4.88 millimeters in total length instead of 5. Obviously there is a tolerance on lots of fasteners and nuts and things like that. So under 2.5%, I thought, good starting point, can we get away with it? As it turns out, and we'll show you that shortly, yes, 2.5% is sort of the magic number. If you can keep under that, then yes, it is almost possible to thread metric on an Imperial lathe. But there are some consequences, and again, we'll have a look at that shortly. So, yeah, probably not going to be threading up to M5. M6, you might sort of consider that, and M6 is pretty close actually, along with a lot of the others. M8 is another fairly close one, so 0.02 millimeters difference between the two pitches. It's not a lot, but it does accumulate. So by the time you've got to 10, 20, 30 thread lengths, then you're going to be sort of 0.7, 0.2, whatever it works out at. It does accumulate, and one way or the other, you're going to either gain or lose threads. So there's a few of these that obviously we can't get close to. So the nearest threads per inch to 1.5 millimeters, 18 and 16. If there were a 17, then happy days, would have been all right with that. But 18, 16 miles away, 6%, no chance. Same with M24, M30, just too far away, 6%, 6%. 4% is a funny one, maybe for certain applications, and if you were generous with thread cutting and give it plenty of clearance, you might get away with that. But definitely anything over 3, you've got absolutely no openings in having a successful metric thread there. So I've got a few examples here of a bit of a Blue Peter moment. Here's one I prepared earlier. Excuse the dog hair. So what I've done is I've already saved a bit of video time here. I've already cut all these on the lathe just to see again how it works out. So we'll start with sort of M12s. This is the first one I did. So you see I've just got a fastener and just cut away. So that is an M12 knot. And as you can see, threads on there, pretty nice. If I picked that up and I picked an M12 knot up, I wouldn't know any different. But if you compare it to an M12 fastener, you can see that, yes, so I keep it to 4 or 5 threads, pretty close. You can still see where the threads are running away. Well, pretty close. And then if you start extending it to 10, 15, 20 threads, you can see that we're already half a thread away there. You're not getting any engagement towards the end because obviously the threads don't line up, and they're never ever going to line up. And it does make a difference when you are threading things of slightly better tolerance or longer than a knot. We'll take this M12 T-bolt, obviously for hold down bolts, quite close tolerances because you want it to hold the workpiece down. Starts quite nice, and then pretty soon, so we're only about 3 or 4 threads in there, and that's your lot. It will not go any further. So because of that accumulated error, you just say no chance. But standard knot, obviously quite a large tolerance, no problem at all. And that's pretty much the story for everything else as well, is that M16, so that's a Imperial thread count, threaded on an M16 diameter fastener. M16 nut on and off, no problem at all. We'll compare it, this is M16 as well. Compare the two, and again, you're losing or gaining threads somewhere, so the first couple are lining up, no problem. But as you get further on, you can see the threads are running out. Now this one actually was a cap head only threaded to about there. I've run that in the lathe, continued with thread. So you grab an M16 nut, and it'll thread all the way down, no issue. But if I try and screw that into anything longer than a nut, so a nut and a half, 2 nuts depth worth of thread, it'll get so far on and just stop. M20, same again, so that's an M20 nut, and tolerances are getting pretty good. Feels nice, but anything more and you're just not going to get it in. And then M24. This was done as an example to say how it definitely, anything more than sort of 4%, 5%, you've just got simply no chance at all. So M24, you can see that they line up bang on. Already after the 3 or 4 threads, we're sort of half a thread out. So an M24 nut will not even screw on. It won't even entertain that. So, as an answer to whether you can thread on an Imperial lathe, yes, kind of. So if I just wanted to extend a fastener that just was just going to entertain a nut, then absolutely yes, you can. But if I was to thread something and it was going into a threaded hole that was more than 1.5 nuts in depth, or the tolerances were quite tight, absolutely no chance. So if you go out there and have a look on the internet, there is actually some information on how you can get a bit nearer than that, because I'm stuck with a Norton gearbox. Yes, I could work and fudge a few threads here and there by changing the change wheels slightly. So if I had a 40 driver, I could probably change it to a 41, and then I'd get slightly nearer to ones that are a bit further away. So there are ways around it. However, am I really going to be buying half a dozen gears or more just to fudge a threads per inch? I'd just be better buying 127 and obviously threading a metric on an Imperial lathe that way. But anyway, I hope you've enjoyed that. I hope that's sort of shown you that certain things are actually possible with incorrect equipment, and that if you're stuck in the desert, for example, and you've only got an Imperial lathe, then yes, you could actually thread a metric thread onto an Imperial TPI, vice versa. So yeah, thanks for watching. Hope you've enjoyed that. Hope it's been educational for you. See you next time.